All right, buddy. Welcome back to another video to help you master AP Calc. This one's focused on implicit differentiation. If you're following this through the playlist, we've already covered basic derivative rules, product rule, quotient rule, chain rule. Now we're focused on implicit differentiation. And then next lesson will be on derivative of an inverse function. So some keys to success for implicit. What is the difference between an explicit and an implicit formula? It's important to know that before diving into this. And then how does the chain rule apply to implicit differentiation? We'll make a direct connection back to last lesson. Then we'll do an example that I like to call level 1 example, very straightforward. And then we'll look at a level 2 example, a little bit more challenging. So what is the difference between an explicit and an implicit equation? On the left-hand side of the screen, an explicit equation is a variable and the equation has been isolated. And it's typically on the left-hand side. So since Algebra 1 or Algebra 2, you've been seeing equations like these. These are considered explicit equations. Y is explicitly defined as 2x plus 1. F of x is explicitly defined as x squared plus 4x minus 5. An implicit equation, on the other hand, is none of the variables in the equation are isolated. So you notice in the first equation there, x squared plus y squared equals 8. Neither of them is isolated. Same for the following, second one. With that, we're in luck. Some implicit equations can be made explicit. So for example, on the left-hand side, we can subtract x squared from both sides and then take the square root of both sides and we get y by itself. That's an explicit equation now. However, some implicit equations cannot be made explicit. This is an example of that here on the right-hand side. So why do we need implicit differentiation? We discovered it or created it, depending on your math perspective on math, whether it's created or discovered, is this allows us to take derivative of implicit equations. If I come back a slide, you've taken derivatives like that if you've done the product quotient chain already. But for implicit, for implicit equations, we need implicit differentiation. So what will implicit differentiation allow us to do? Make sure you got that so far. That will allow us to take the derivative of an equation, even if it's written implicitly. So how does the chain rule apply to implicit differentiation? Implicit differentiation comes from the chain rule, directly comes from the chain rule. So we might see an implicit equation like this, y squared plus 3x equals 24. We can think of the y variable as a function of x. Another way of thinking about this is to write the equation as such. Instead of thinking of just y, we can think of the y as a function of x. And so we can think of that as f of x. Then on the left-hand side, f of x is an inside function to x squared. So if we apply our chain rule on the left-hand side, we would get 2 f of x times f prime of x. When we take the derivative of 3x, we get just 3, and then derivative of 24 is 0. We can then isolate for f prime of x, and we get negative 3 over 2 f of x. On the right-hand side, it's going to be the same process, but I'm going to show you how to do it if we just leave y as y, and that's how we'll do our following 2 examples. So differentiate the following equation with respect to x. When I take the derivative of y squared, I want to remember that is a function of x, so I need to apply the chain rule to it. So that will become 2y times dy dx. 2y times dy dx. The dy dx there, you may write that as y prime. I like to write as dy dx so it stands out more, but you could write that as y prime. Then derivative of 3x is 3. Derivative of 24 is 0. Then I go about isolating dy dx just like it's any other variable, and dy dx equals negative 3 over 2y. Notice how this part on the right and the part on the left are the exact same thing, where we saw y, or we see y is f of x. When we see f of x, that's where y's position is. Just looking at the 2 different forms of notation, I think the left side translates a little bit more to chain rule. The right side is more often how you're going to see a question like this one, though. So concepts CFU. When we see an equation in terms of the variables x and y, we differentiate with respect to x. How do we treat the variable y? Pause the video, think about it. We treat the variable y as a function of x, and we apply the chain rule. So now what happens if we change the variables? If we had an equation in terms of b and z, and we differentiate with respect to b, how would we treat the variable z? Think about it. We treat the variable z as a function of b and apply the chain rule. Something to notice here is that we're just changing the letters in what we're differentiating with respect to. In the first question, it was x and y. In the second question, it's B and Z. You want to be flexible with looking at different variables. That'll help you out later if you're tackling a related rates question. So implicit differentiation, level 1 example, here we got it. I've got it written on my paper, so we're gonna switch to the doc cam so you can see this more clearly. If you're following along, take a moment to copy that down by pausing the video. So here we go, same example you just saw on the slide. Let's jump into this one. Consider the implicit equation given below. Okay, is this implicit? Yes, a variable is not isolated. Determine an expression for dy dx. So I'm looking for the derivative. That is what I'm looking for. So from there, I'm going to take the derivative of each term moving from left to right. I'm just going to write those directly underneath as best I can so we can follow. Derivative 3x, that's just 3. Derivative 4y, that's going to be 4, but applying the chain rule, we get dy dx just like that. Plus, I know derivative 5 is just 0. Then we get derivative of 3x squared with respect to x, that is 6x, plus derivative of 5y squared, that's going to be 10y, but then don't forget your chain rule, times the derivative of y with respect to x like that. Then from here, we are just trying to isolate dy dx here. We're just trying to isolate that. So we're going to move dy dx to the left and all the other terms to the right. All right, so we're gonna have 4 dy dx here. We're gonna bring this over, so it's gonna be minus 10y dy dx equals 6x plus 10y minus 3, just like that. Still looking to isolate this part here, so I can factor that out, dy dx times 4 minus 10y. You could use parentheses if you'd like. I'm just using brackets because I feel like it. 6x plus 10y minus 3. Almost there, isolating the dy dx. Dy dx equals 6x plus 10y minus 3 all over 4 minus 10y. And we have answered the question. Take a moment to pause the video, recap any of that if you got stuck. I'm headed back to the PowerPoint. All right, so we just tackled example 1. I like to call that a level 1 example because it's very straightforward, no curveballs. Example 2, on the other hand, we are going to see some curveballs. So if you're following along, take a moment to copy that down, pause the video if you need to, and I'll see you on the doc cam. All right, here we go. Second example. Let's get to it. Consider the implicit equation below. Okay, here's that implicit equation. Determine the value of the slope at the point, that should say at, sorry about that, at the point 2, 2. All right, a little bit different here now. I'm trying to find the value of the slope, and I know when I'm looking for slope, I'm looking for the derivative, and then I'm given a point here. So I'm actually told x equals 2 and y equals 2. That might be helpful. And then I have this implicit equation. So if I'm looking for the derivative and I have an implicit equation, I'm going to need implicit differentiation. And then I might use these points in a clever way. Stay tuned for that in a moment. But first, we need to take the derivative. So when I look here, I have x squared minus xy plus y squared. Take the derivative of x squared, that's going to be 2x. Then this next part gets a little bit tricky. I have minus x times y. So that's going to be a product rule here. I'm going to write that with parentheses like this. As you get faster at this, you'll see some other cool tricks. Keep the first, derivative of the second, plus second times the derivative of the first. I kept the x, took the derivative of y, which is dy dx. Kept the y, took the derivative of x, which is 1, like that. Plus, now I'm taking the derivative of y squared. That is 2y dy dx equals 0, just like that. So now there's 2 ways you can go about it here. I could do the same thing I did in example 1, where I try to isolate dy dx. You might prefer that. That might be the way to go in an FRQ. If you're crunched for time, I'm going to show you a quick way to use these points to get to a answer even faster. So follow closely for that. So I know I'm looking for this, but I have all these variables. I'm going to use these points to substitute in for x and y so that I can solve for dy dx. So 2x, when I do 2, I'm just going to show the substitution so everyone can see that. 2 times 2 minus 2 times dy dx. Y is 2 plus 2 times 1 plus 2 times 2 dy dx as well equals 0. From there, I'm going to simplify. I have 4 minus 2 dy dx minus 2, make sure you distribute that negative, plus 4 dy dx equals 0. Then from there, I can combine these two. That's going to become 2 dy dx equals, bring the 2 over, that'd be positive 2, subtract the 4, that's negative 2, and I get dy dx equals negative 1. If you went the other route and decided to isolate for dy dx first, you would get the same answer. Just wanted to show you some diversity of thought there. Answer should be negative 1 regardless. Headed back to the PowerPoint to close out. So we just tackled example 2. Some wrinkles that made that more complicated are as it asked for the slope, which we had to infer was the derivative, and it gave us the 0.22, and we had a secret, not so secret actually, product rule there in the middle. So to recap, our keys to success on the chain rule, which is what we're working on, is make sure you know the difference between an explicit and implicit formula. If you're trying to find the derivative implicit formula, you gotta go to your implicit differentiation. And then we saw how the chain rule applies to implicit differentiation. Implicit differentiation level 1, we did a very simple example, and then we did a level 2 example with a few more wrinkles, so that you're prepared for the AP exam. With that, that wraps up implicit differentiation. The final video in this sequence is going to be derivative of an inverse function. If you have any feedback, please let me know. Hope you found this video helpful on your way to mastering AP Calc.